is close, and now you have to make sure you make your problem look like a formula in some way. What can I do here?
You split apart, split it apart so that it's to 2 and then the X in the other part.
Can I do that? How would you simplify that where I have this to a power to another power? It's the same as multiplying the two powers. So because this is 2 times 1 over h, I can leave the 1 power sitting there and move the other power outside. Why would I want to do that? I mean, this is a little bit more effort to say this, but move that limit part inside. There's some technicalities there, but for anything that you do, you're allowed to do that. You have to justify it. What was the point of that? Rewriting it that way? The part in the bracket is what? The number e. Anytime you see this formula or this expression, you can say, hey, this is the number e. And I just have a 2 sitting there. So this limit is the number e squared. If you find that out. You just have to find a way to squeeze that formula into there. So another one, I guess it's similar to this. Let's find the limit as x goes to 0. Now we're going to like my definition is similar. 3x divided by sine of 2x. This is why nobody likes math. In our mind, this is the same idea. Feel free to ask any questions and stop me. Like, the nice thing about having all the videos that you can pause and rewatch, it gives more time to answer questions. Were there any formulas we were given that had x's and signs in them? So this is actually one that's in the notes that you can just memorize. What is this limit? 1. There's a proof of it in the book if you're really bored. So if you read the book, they definitely hit this one with a sledgehammer. That limit value is 1, your last piece you said. That is something you can memorize. All right. Another thing you could say, the limit is theta goes to 0. Sine of theta divided by theta is equal to 1. What's the difference in these two? Anywhere I had an x over theta. It's really the same statement. You guys have the choice of variable doesn't matter. Right? Saying x goes to 0 or theta goes to 0, and all the thetas, all the x's in the same place, it's the same statement. The choice of letter here doesn't matter.
So it's a 1.
So how can I solve this one? So what do you know? Sine of 0 is 0, so this is like a 0 over 0.
So that's like the h of this definition.
Yes.
Okay, so you replace it.
Yeah. Okay. I was making a point to somebody. Perfect. Alright. So what do I do here? These don't quite look the same. What should I choose for theta? I'll call this a bonus question. This is really, don't do this because otherwise you lose points, so it's the opposite of a bonus. Is that true? Can I take a 2 outside of the sine function? Please don't. How can you know that might be wrong? I mean, I wrote it in red, but I hint that red means wrong. If you're asked to find sine of 2 times an angle, what would you have to use? Something that nobody memorized, but it was awful at the time. Double angle formula. When you plug into the sine function, you plug in angle, so this is a double angle. So if you wanted to figure out what this was, you had to use the double angle formula, which was awful. It was like 4 things to plug into. You have to do all that because you couldn't just move to the outside. The other way I think of it is, sometimes sine of something is equal to 1, right? What if I put a 2 here? This is equal to 1. Now whatever this value was, I'm getting a 2 out of it. Can I plug something into my sine function and get a 2? That's past the amplitude, right? If I plug in the sine, I have to be between -1 and 1. I can't randomly jump up to the y coordinate 2. So, which is why you have to do the double angle formula. You're corrected for that. So, the point of all that, no matter what, there's a 2x inside. I'm not getting rid of that. By moving the 2 out, what were you really trying to do? Here, there's nothing else inside, right? It's just one variable sitting there. That's what I need. So I would say, let theta equal 2x. Which means x is equal to 1/2 times theta. And what happens? I have x is going to 0. But instead of writing my problem in terms of x, I want to write it using theta. Right? I had this symbol x sitting there, now I want to switch to the symbol theta. How can I do that? What is theta in terms of x? It would be 2x. Now I can't just plug in here because I didn't tell you where the x's are, so when you plug in. But we said theta is the same as 2x. So what is this limit? How do you find limits? What's your first go-to? Don't forget the easy thing we always start with. Like we're doing hard stuff now, but we still at some point want it to look like the easier ones. Just plug in the number. If you plug in, what do you get? 2 times 0, so you get 0. So this problem is the same. This says x going to 0. Or what this really says is that x goes to 0, then theta goes to 0. So instead of taking the limit when x goes to 0, I could change my whole problem to be the limit as theta goes to 0. So I find the limit when theta goes to 0 of 3 times x. What's x equal to? 1/2 theta. And then divide by sine of, instead of 2x, I can just write a theta in here. had a problem that only had x's. Now I have a new problem that only has thetas. Why did I want to do this? I wanted to get this 2 outside, but I can't just randomly move it. So this is what, 3/2, so 3 halves, limit of theta goes to 0. Theta divided by sine of theta. Is that the formula I have? Not quite. It's close. What's wrong? Yeah, I have them switch. So I really need a reciprocal, right? So probably writing an extra step that is worse than just explaining it. I really want this, right? Then it would look like my formula. Am I allowed to just randomly flip those? That would change the inside, right? So if I do that, I need to raise it to the -1 power. Now are those the same thing? -1 power says take the reciprocal, so if I do that, it flips them and it matches what I had before. Why did I do that? Now, so what would be the limit of this, the inside part? Can we go to 1? Because that limit exists, I'm allowed to say this. Basically, we always say plug in theta equals 0. What are you really doing? You're plugging in this limit value. So what would this be? So what's the whole inside part? That's the one we memorized now, right? That limit must be the number 1. So this is the part you're given for free, but then we said that's equivalent in terms of data. So if I want to change variables, it doesn't matter how I rewrite this. So this is exactly the thing we said must be 1. That's just one you memorize, that's something you get for free. So this is equal to 1 to the -1. What's 1 to the -1? 1/1. Still 1. So I get 3 halves. So another one that's similar to this, I'm going to make it match the video. So the way I explain that might be a little bit different than the way you see the video sometimes. I do want to mention this is change a variable. If I, instead of writing x's, pick a new variable h, pick a new variable theta. Can I rewrite the whole problem using that other variable to make it look easier? Some of the ones in the there is a video that does it where it's like u is equal to e to the x. So instead of sending x to a certain value, what value does u go to, and then it factored nicely, everything gets written nicely. That is in the notes, so I did want to highlight it. But it's basically, this looks hard in terms of x, let's write it in terms of something else. And get rid of some of the hard parts. Right. For the trig one, like this, I'm going to switch to this one. There's a slightly different technique that was mentioned. So you could do it the same way that I just did with change variable, but there's a little bit of a shortcut here. What's the big thing in this formula? The inside and that bottom part match. And I'm going to 0. Just make that happen. I have 2x on the inside. That means I really want a 2x on the bottom, right? And then you can say let that equal 2x, and match. But can I just randomly divide by 2x? Nope. What do I need to do? If I divide by 2x, I need to multiply by 2x. Otherwise, I change the problem. And then what was left? I still had a 3x sitting here. Why did I do all that? This is what, 2/3? So 2/3 limit as x goes to 0 of sine of 2x over 2x. X over x went away. What would that limit be? This goes to 0, so it's still the 0 to 0 form. But this part is exactly this part, so this whole limit must be 1. Negative 2/3. I mean, we're not doing it, but you could say this part is the same as theta goes to 0. Sine of theta over theta, where theta is equal to 2x. Basically, I replace 2x with a symbol. And in that symbol, everything works out the same way. You could do the same change variable. Sometimes we don't, we just do it in our head. I would accept either. Any questions on that one? There were 3 formulas. The sine one, the e one, and there's one with cosine, where the limit ends up being 0. 1 minus cosine over 1 minus x or something. Or x. So I want to do a few examples of, in some ways, formulas are nice, you have an answer, but the problem we give you, you now have to rewrite to make it look like a formula. And working in a formula is sometimes harder than just solving other problems. Right? That's where you need to make sure you have your goal in mind. I want to make it look like this, what would I need to do that? All right, one other thing I want to mention. You want no credit? Do this. Everything I just did is correct, and you will get no credit. Because this whole technique where I did no real effort is section 3.6. And if you're using section 3.6 on the Unit 1 test, I'm concerned, or especially in the homework. If you're using section 3.6 in your homework, did you come up with that on your own? What does that circle H stand for? That's just copying garbage right there. If you have no idea what that symbol means. It's a little note that we put there to let people know we use L'Hopital's rule, which, if you don't know what L'Hopital's rule is, you probably shouldn't be using L'Hopital's rule in the middle of a test or homework. All right. We will cover section 3.6, and you're allowed to use this shortcut. In your final exam, a lot of the limits that you remember being awful from chapter 1 will suddenly be less awful. It would make all the E stuff like free. It's the trick we need to answer that one question you had asked to make it much easier. But that shortcut requires pretty much all the content in chapter 2 to even motivate it, to then use it in chapter 3. Okay. Make sure you're using things that are self-contained. There aren't many where we just say no credit, but that is one where that is obviously not chapter 1 work. And it stands out to us. I mean, I took a sine and made it cosine just completely randomly. When you look at this and you look at this, why in the world are those two equal? That looks like magic. Or garbage. One of the two. Right? But we see this a lot. I mean, here we have in-person tests. It was way worse a year ago when we had at-home tests. And then you get nice, correct solutions that some of them use material from Calc 4, some of them use material from graduate level math. That raises red flags. Right? If you're, any tutor here won't be doing this, or they would know not to. But if you're using online tutors or anything, those paid help sites, all bets are off. They do things they probably shouldn't be doing and give it to you. Right? Alright, let's do some other random problems. Oh, I had, let's even show. Oh, I'm going to put it right forward. Here's that function we just had. We said what, find the limit x goes to infinity. It does very much level off to the number 2.7 something. So that's plugging in x equal to 125. We'll keep going. It's pretty convincing this is a horizontal line now. And the limit is roughly 2.71. The exact answer is number E. This one is also similar. This is another form of it. You go off to the right or the left, it still works. There is a horizontal asymptote sitting there, and it is at the y coordinate. So you can see these are getting roughly to 2.7 something. These are coming from the other side. One's above the asymptote, one's below, but they are leveling off. So you can always graph this and see what's happening. It just happens to that. Which is good, we told you it would. Alright, let's do some other things. Let's find the limit when x goes to -1 from the right. -3 divided by the natural log of x plus 1. Alright, so we're done using the formulas. That was kind of a topic kind of thrown in at the end of this section that I wanted to spend a little more time on. This is closer to what most of the section is. What do we try first when we find limits? Plug in, see what happens. So what would happen here? -3 over natural log of 0. What's natural log of 0?
1. 1.
Natural log is 0 plus, right?
Well, if you want to spoil the surprise, yes. Before a test, definitely memorize the graph natural log of x. You always, there's these basic graphs, you want them memorized so you don't just guess values. What would be natural log of 0? Have a vertical asymptote there? So I can't plug in the number right here. Natural log of 0 is undefined. Natural log of 1 is 0. But if you have that basic graph, you're going to realize 0 is messed up. It's probably 1. Okay. So then, yeah, how do I solve this? So from here, I would say that looks roughly like infinity, or negative infinity, but I have to make sure I'm coming from the right. So I'll write it this way. -3 over natural log of -1 to the right plus 1. This is showing an extra step in what might be involved. So here's my number line. Here's -1. And I'm coming at it from this direction, right? And now I want to add the number 1 to it. So -1 plus 1 is equal to 0. Which side am I coming in from? Must be coming from this side. Basically, I move 1 unit over. Why is that relevant? -1 plus 1 is 0. When I write natural log of 0, it doesn't make sense anymore, right? If I had 0 coming from the left side, there's no graph over here. None of that would even make sense. Or that problem would not be well defined, or, well, you just say it doesn't exist. But really what's happening here, this is natural log of 0 coming from the plus side. The hard thing is when you plug in and you get 0, you always need to figure out is it 0 plus or 0 minus. And then you have to go back and check. You know, if you plug in -1, I didn't start at 0 plus or minus. But then I took -1 and did something to it. So you always want to make sure you're coming, when you write 0, it's either plus or minus correct. You have to track all the signs and make sure it's correct. Now what happens?
You know that the bottom is going to be trending. If it's approaching from the to the left, then it's going to be trending towards negative infinity.
Yeah, coming from this plus side,
Yeah.
falling down to negative infinity.
Mm-hmm.
All right. So what's -3 divided by negative infinity? It's positive. Okay, we can say that. What's 3 divided by infinity? Make precise things. Well, confidence. Unfortunately, we can't just vote. It's not even like majority rules. Is there's one answer, it's right or wrong. So everybody loves and hates that math. We always get that. Why don't we get more, like, you know, very holistically? It's wrong. It's not an essay. You can't convince us this is any answer but 0. Definitely have those forms memorized. So, does that one make sense? A lot of these will play out similar to this. That's kind of why I wanted to go through these. The big hurdle is, we would say this was a non-indeterminate form. Basically, did I ever do anything like factor cancel or anything? All I did was keep rewriting it in these non-indeterminate forms until I knew what the answer was based on counting negative signs and using things like 3 over infinity is 0. So really, all I did was plug in. As far as our approach is to finding limits, you can plug in. Ideally, you just get a number out of it. Or you can plug in and kind of keep track of these non-indeterminate forms and still basically just get a number in the end, or an answer. I don't have to do factor cancel. The hard thing is keeping track of all that. So, limit as x goes to -1 from the right, -3 times the natural log of x plus 1. So I just plug in it's the same issue as natural log of 0, right? But anytime natural log is 0, I know natural log has a vertical asymptote of 0. So now I need to make sure it all lines up correctly to use that. So this can be -3 times natural log of -1 from the right plus 1. So we already know this has to be 0, right? Now the question is it 0 plus or minus? Plus. In which case this goes to -infinity. So I get 3 times infinity. What's my answer? Positive infinity? One that looks almost the same. What happened here? If I tried to plug in, it would be 3 times natural log of -1 minus -1. So -1 plus 1, so I get 0. Same issue. This is going to be 3 times the natural log of -1 minus -1 from the left. So we know it's 0, but I need a plus or minus sign, right? I could have easily come from the left and this makes absolutely no sense. I've reversed everything, it looks awful. When in doubt, draw a number line. Where was I? I was at, or what would this be? I'm starting at, what? I'm at -1. On the left side of it. And then what happens?
Basically, one, two.
Yeah, so this is the easier way to see it. In case you're not sure what's happening here. -1 minus -1 to the left. I could factor out a -1 and say that's 1 plus -1. Is that true? Fix the negative sign issue. So what number is this? Starting at -1 on the left side, and now I'm moving over 1 unit because I added. So I'm going to be at 0. It's still coming from the left side. And what's a -1 times 0 minus? I treat this like a negative sign.
No.
0 minus means I'm on the negative side of 0.
But it doesn't mean it's negative.
Yeah, we're treating it like a negative number.
Okay.
0 minus says you're in the negative. You're on the negative side of 0.
Okay, I didn't know you said.
Yep. So the reason we track it, we treat it like a negative sign. So then what happens here? If I have a negative times a negative, I get 0 plus. The negative part goes away. So 0 minus says I'm coming in from the negatives, so it's not quite 0, it's something just slightly negative. And then when I switch it here, now it's positive. 3 times negative infinity, I keep the negative sign, my answer is negative infinity. Be really careful with positive negative signs. The easiest way I've always thought to do it is draw a number line. If you're not sure, you need to convince yourself. You can draw a number line and really draw in what's happening. There's no reason, I mean, you can always break these down. The hardest thing with this section, you can answer a lot of problems with like 2 lines of work. But then what happens when you make a mistake in that 2 lines? There's really not much room for partial credit anymore. You drew a number line and then got the wrong sign, but had it mostly convincing. That is worth a lot more partial credit because you knew what you were doing and knew what to track. Okay? So this is one of those, it's easy to not show much work, but you really do want to show a little bit more work in this section. All right. Have a good weekend. Long weekend. Hey, no problem.